Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, an introduction to secure infrastructure as code using Terraform, brought to you by NewVector. We have an awesome webinar for you today, as usual, but before we get started, I need to go through some housekeeping items with you. First of all, please remember that this session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at devops.com/webinars, and it will be there for you as well. We are taking questions throughout the presentation, so you can use the Q&A tab on your webinar console to submit those at any time. We will try to get to as many as possible at the end, so stick around for that. And also stick around because we're doing a drawing for 4 $25 Amazon gift cards, so stay tuned and see if you are a winner. All right, with that, I am pleased to introduce to you today Glen Kosaka. He's the VP of Product Management at NewVector. Glen, I'm going to put myself on mute and turn my camera off and let you get right into it.
All right. Thank you very much. Thank you, everyone, for joining me today, wherever you are. Today, I'm going to talk about one of my favorite topics, which is around automation. And so we're going to talk about, there's been a lot of coverage and hype about the topic of infrastructure as code. So we're going to talk a little bit about what that is, start with the basics. But we're going to focus on today's webinar on security. And so as the title says, it's not just how you can use automation to deploy infrastructure as code, but how can you deploy it securely? How can you get it right in the first place so that it's got as many protections as possible against all of the hackers out there? So that's what we're going to be talking about today. I'm going to give some examples of various Terraform examples that one of our engineers has prepared. And then I'll also get into how to automate some of the NewVector security features. All right, let's dive right in. Oh, and there is a blog post that we've written, a two-part series that you can see the link to at the bottom there. And these slides are available for you if you want to download them or just run through them later to see these links. All right, so let's start with the big picture. I like to say it's the need for speed. The big opportunity for modern application development is to be able to rapidly deploy new applications or update those applications, perhaps as often as 10 times a day, 100 times a week, 1,000 times a month. Some of our big tech partners, Google and others, are deploying tens of thousands of updates every month. And how are they doing that? Do they have people manually building new releases and going through their waterfall processes to test them and put them out there? No, they have automated pipelines and they need the ability to send new applications through those pipelines. But it's really more than that. It's the ability to deploy or extend the infrastructure on which those applications run automatically and very, very quickly. So all of this is really enabling larger scale deployments. So if your application suddenly becomes popular or one part of it becomes popular, your application can just scale up. You can deploy a new cluster if you need to in a different region to start taking some of that traffic to that application. In addition, some of the major benefits of IaC and this automation is the ability to reduce costs. And how are you going to get cost reductions? Well, it's really in the ability to better match the computing resources that are required for your application to the actual infrastructure that is available. In the old days, you had to have all these data centers sitting around just in case your app got busy. And if it got busy, you'd need to run that entire application in that big data center, rather than just scaling up that part of your application or microservice that got busy, and being able to scale just the resources needed for that. So by better matching infrastructure resources with demand, you can reduce your costs. And as we talked about, highly automated operations are really a requirement to achieve any of these benefits. So let's start with the basics on infrastructure as code. It's really the ability to express these resources that you need as code. And the world is moving to more of a declarative model, where you declare the desired state, whether it's security or whether it's the servers and the network and the virtual, the VLANs that you need, VPCs. You declare what you need, how much of that you need, and the state of that, and any configurations of that. And by using a declarative model, if you need to change any of that, you simply change the declaration and push that through, and everything can just update. So it makes it very easy to change or update the state of your infrastructure. And that could be for scaling reasons, that could be for changing configurations, that could be for making it more secure, any of those possible reasons. Now, a bit of terminology background here. We're not talking about application code. That's, you might be thinking of as software application development code. In this context, we're really talking about, when we say code, we're talking about things like, in the case of Terraform, HCL, HashiCorp language, or it could be just JSON, or another popular format is the YAML format for declaring the state. So, that's what we mean when we say code in this context. And scripts, just scripts that have been written. We really don't consider that as code, so to speak, when we're talking about that now. Now, why couldn't we do all this before with scripts? Why now? Why is this possible now? Well, it's really possible because today, because of all the virtual infrastructures that all of the public cloud providers provide, they're going to handle all the messy little details that were necessary in the past that you may have had to script. And they're only going to expose the major decisions that you need to make about the resources that you need to deploy. And that's what can be expressed in this code. So that's what's really changed in the landscape that enables this. Now, what are the benefits of infrastructure as code? Well, as we talked about, one of the major drivers is automation. So speed, the ability to quickly get new resources up, or to extend existing resources, or even to change the configuration of existing resources. Another major benefit is consistency. There's been a lot of problems, especially with scripting. Joe has written a script on how to deploy a new server instance and all of the configurations, even perhaps all the SE Linux and security settings and access controls for it. And it's in some cryptic way that Joe has written that script. And when Mary needs to take that and deploy the same infrastructure in a different data center, it's difficult to understand. There can be errors introduced. It may be slightly different hardware specs, so some of those values are not going to work. And so therefore, you're going to get inconsistent deployments, and that can lead to insecure deployments. So consistency is a major benefit of infrastructure as code. And other benefits we talked about are scalability, the ability to scale resources, cost reductions. And then finally, our topic for today is security. by consistently deploying a set of resources with a set of configurations, we can improve the security of that infrastructure. So hence the term secure infrastructure as code. And oftentimes people forget about security when they're getting their new clusters up or don't spend enough time really diving into that. Perhaps because they don't understand all the the attack surface of new cloud infrastructures, or understand how networking and firewalls work, or how they should be configured in this new infrastructure. So if we talk about Terraform specifically, as I mentioned, Terraform uses a certain language, HCL, which is their format, but it is compatible with JSON. So the benefit of it is any of these languages is it's human readable, that you can easily scan those, you can see where the important values are set, and you know where to make changes. In the case of Terraform, there's many modules and providers available for all cloud providers and even on-prem deployments as well. And it's very simple to use Terraform to initialize infrastructure and then apply, which is to actually deploy the infrastructure and then to remove it. So if you need some compute resources, either for testing or for an application, a new application module, and you need it just for a week, you can do that. Or if you need it for a few hours, you can do that. And so it makes it very easy to get infrastructure up. So I put a couple links here on some resources that you can go to, take a look at him. So this is the HashiCorp configuration language, HCL, describes the syntax of the language and provides some examples. And then when we go to Terraform, we can see under their Terraform registry, provider registry, some of our examples will use Google Cloud, but they're all very similar. So if I click into Google, you can see there's a bunch of pre-made modules that have been provided by the provider. In this case, for example, this is how to spin up a Kubernetes cluster using Terraform on Google Cloud. And there are default examples, which is going to deploy a very simple Kubernetes cluster, managed Kubernetes cluster with a default node pool. I believe in this case it's 1. But you can change any of these configurations. And down below, you can see all of the possible input values that you can examine and change in these modules. And so we'll pay special attention to things like, adding firewall rules, login and user configuration, access controls. So there are firewall inbound ports. So these are all the things to look for in terms of security. Anything to do with network rules, firewall rules, network policy. So there's a number of security configurations that can be done when you deploy your infrastructure. So those are all things that should be reviewed and then can be configured before you deploy your new cluster. And also another resource we provided under this GitHub link, DevSec Labs, is a number of examples that I'll talk about today. So, we have a very simple one that is just deploy a simple GKE cluster. And it's using the examples that we just looked at to deploy a simple GKE cluster. And I'm not going to actually run those examples today. We do have instructions on how to do that on the blog post that I showed earlier. And we have done kind of hands-on demos in the past. And if you're interested, we can provide you with links to that as well. Now, so I've already started to talk about what is secure infrastructure as code. It's basically when you deploy an infrastructure and any applications on top of it, keep in mind all of the different security settings that are possible and that should be configured when you deploy your infrastructure. Critical ones include any access controls to the cluster. Of course, a few years ago, you may have heard about the Tesla hack where Kubernetes cluster was left open, the management plane, and hackers were able to get in, escape down into the EC2 instance and install crypto mining. So any type of access controls, of course, are critical. Firewall rules, SE Linux configuration settings, all of those things should be examined and configured before you deploy your infrastructure. Now, going beyond that, once you deploy your basic infrastructure, let's say a Kubernetes cluster, you can deploy a security solution, which is part of that infrastructure and should be considered part of your infrastructure. It's really a security layer on top of your infrastructure. And that will serve to continuously audit the configurations of your infrastructure, as well as provide real-time runtime visibility and protection. So you can tell if hackers are trying to get in, if certain types of attacks or suspicious network connections are occurring and things like that. So I'll show a little bit about more about that later. And so when I show NeuVector, before I show NeuVector, I thought I would give a brief overview, high-level overview of what NeuVector is. So NeuVector is a full lifecycle container security platform from pipeline all the way into production. And it's really two major areas: vulnerability and compliance management and runtime. On the vulnerability and compliance management side, it starts with the build scanning step. So when developers are building their images, NeuVector can be invoked, whether it's through a Jenkins plugin or Azure DevOps or GitLab. Any of the pipelines that are being used by your developers can then invoke the NeuVector scanner to check for vulnerabilities and compliance violations. And that build phase of that pipeline can be failed. It can be kicked back to developers under certain conditions. So for example, if it's a critical vulnerability with a certain rating and there's a fix available, because if there's no fix available, then the developer can't remediate that. And let's say it was published more than a week ago, so there's been time to update to the latest version. Then in that case, you can fail the build, and then the developer has to remediate that, send it back down the pipeline. It's scanned again, everything is great. Then it goes into a registry. And from there, registry scanning and runtime scanning kick in. Now on the runtime side, we'll start in the middle there with admission controls. After NeuVector has scanned an image in a registry for vulnerabilities, NeuVector can block unauthorized or vulnerable deployments into that production environment. And we integrate with the Kubernetes and OpenShift admission controller to be able to do that. So you can set up a policy that says if it's got too many vulnerabilities, or if it's going to run as root, a number of different criteria can be used to block that deployment. Now, once that deployment is in the production environment, we provide what's called a container firewall and workload security to protect that workload while it's running in production. And we're using something which is more of this declarative model that we talked about, declaring the state of infrastructure. We use the same thing. You can declare the state of the security rules and the allowed behavior of your applications. So for example, you're able to declare what network activity your application is going to invoke. Is it a connection externally to an API service? Is it east-west traffic? What protocol is being used? And then further, what processes and file activity are your applications going to use? And once you lock it down, anything else is deemed suspicious. So we're able to automate all of that by learning the behavior of your application and then exporting that as security policy as code. So I'll talk a little bit more about how security policy as code can fit into this whole concept of secure infrastructure as code. So if we look at our next example, a basic configuration would be to deploy the NuVector solution as part of your Terraform deployment. So what we're talking about here is, let's say you need to deploy a new cluster to get your compute resources going. You can, at the same time, in your Terraform example that we show here, can deploy NuVector, which deploys all of the containers to deploy NuVector. And in this case, it's going to leverage the Helm module or the Helm chart that's available for deploying NuVector to be able to configure and deploy that using Terraform. So that's the example that we show here, Helm Basic NV, in this link that we show here. Helm Basic NV deploys kind of a basic deployment of NuVector using Terraform. Now, the other thing we can do is we can go further than that. We can do not only deploy the NuVector security layer, but we can configure it. And in addition to that, we can actually deploy our application containers. So in this example, what we show is the ability to deploy the NuVector security platform. Of course, being enterprise software, it requires a license. So to automatically deploy that using the Terraform scripts we've provided. Do the initial configuration using config maps. Config maps is a Kubernetes construct where you can define a lot of initial configuration for any software product. So for NuVector, it might be things like integration with LDAP or OIDC so that you can have user sign-on, integration with your SIEM and notification systems, initial configuration of basic security policies or registries to scan. All of those things can be done through a config map. And then in this example, we take it even further where we have an application stack, which is really, think of it as if you have an application that you need to be able to set up and run on any public cloud very quickly, you can automate that through Terraform as well. But what we're going to do is we're going to show that before you deploy your application stack, you really need to deploy those security policies that we talked about that are going to define what that application is allowed to do, what kind of behavior is it allowed, so that anything else can be monitored for suspicious activity. So in the example 3 here, we actually deploy using a Kubernetes construct called custom resource definitions, the NuVector security rules specific for this application stack before we deploy that application. And therefore, when that application starts to run in this cluster, it's already got the protection enabled. There's no need for anybody to log in and create rules or to do any learning in the production environment. So this example here is called the NV deployment example. You can see it here. If we click into it, you can see all the various Terraform examples and modules, some of which are scripted to use the NuVector REST API. Some of them are running scripted to deploy the application stack that we talked about. And we even can deploy the CRD that we talked about. So right here, if you simply clone this and do a Terraform init, this will deploy, assuming that you have your Kubernetes cluster up and running, this will deploy NuVector, it will configure it, it will apply the license, it will deploy the protection CRDs for the applications that are going to be deployed, and it will actually deploy the application stack. And you can imagine it's very simple to combine this with a deployment of the actual cluster so that you can deploy your GKE cluster or your cluster on AWS or Azure, and then deploy all the security layer and your application automatically. And this really can be accomplished in a matter of minutes to do this deployment. I think the longest time that it would take would really be bringing up a new cluster, because VPCs have to be set up by the cloud provider and things like that. So that may take, let's say, 10 minutes to deploy a new cluster, and then a couple more minutes to deploy this full working application environment that is secure. So there are really endless possibilities for automation when you're thinking about secure infrastructure as code. You can extend it all the way into the build and Jenkins pipeline, as we talked about, making sure that whenever you're bringing up a new pipeline, that you're automatically integrating vulnerability scanning and compliance scanning into that pipeline, and you're creating the set of rules that govern when build jobs are going to be allowed to go through the pipeline and when they're going to be rejected. So think about what types of things in your environment you would like to configure. You would love to see some examples that either you're doing today or that you'd like to see, putting that in the question and answer or in the chat. Now, I'm going to flip over to getting a little bit deeper into NeuVector and how we can automate all the different automation and integration points for the NeuVector security platform, so that we can make sure that when the infrastructure is coming up, all the initial configurations of firewall rules, access controls, Kubernetes, all those are done. Then once we deploy the NeuVector security layer on top of that, what are all the things we should look for to try to automate? All right, so this is the NeuVector security console. NeuVector, by the way, is a set of containers. So there's a control plane, there's what we call an enforcer, which deploys onto every node in the cluster and does all the scanning and packet filtering. So if I look here under my assets, I gotta log in again. If I look under my assets, I can see that I'm running a certain version of Kubernetes. Google's doing a good job. There's no vulnerabilities on that. That's on the orchestrator itself, Kubernetes itself. And then NeuVector will also, because we have the auto scan turned on, will also vulnerability scan each of the host or the worker nodes that are in the cluster. Now, so this auto scan button is the first area that we'd recommend that after NeuVector is deployed, that this be turned on as part of your automation. And what that does is it starts to do any of the runtime scanning. So like we're seeing here, the orchestrator gets scanned, the nodes get scanned, and any container that starts to run also gets scanned for vulnerabilities. Now, in addition to vulnerability scanning, there's also compliance scanning, which is, in the case of hosts or nodes, Kubernetes CIS benchmarks. In the case of containers, they would be more like Docker CIS benchmarks. And we'll look at other compliance scanning tasks for images in a minute. So those are the hosts that we're running on. These are all the containers. I'll come back to registries. The thing I wanted to show was just to give you a sense of what's going on here is in this cluster, there is a controller, which is our control plane, and a leader has been elected. So there's only one needed, but 3 are there for HA reasons. It's really the brains or the policy management. We also have enforcers. The enforcers are deployed as a daemon set on every node, and they're doing all the packet inspection, the runtime protection, and also the vulnerability and compliance scanning on every host. And then to do the registry scanning, other types of scanning activities, even pipeline scanning, we have one or more scanners that can run. And this, as a default, is 3 scanners that run. These are scalable pods. So if, for example, you have 100,000 images in your registry and you need to periodically rescan those for vulnerabilities, these can be scaled up to 10 pods or 20 pods, however many are needed to get through that many images in a reasonable amount of time. And by reasonable, 100,000 images may take a day to complete, but NuVector is really the fastest and most scalable scanner, and we'll be able to complete that job, whereas other scanners may not even complete that job, so you'll never get those scan results. So those are the system components that NuVector deploys, and as I mentioned, once we're deployed, we start to do scanning automatically. Now, typically, we talked about the build process of building scanning into your Jenkins pipeline. That can be accomplished by a scanner kind of running outside of this environment. And then once the images pass that environment, they're typically put into a registry. And so NuVector can continuously scan the registry to make sure that there are no vulnerabilities. And even if it's past your scan in the build pipeline, there may have been new vulnerabilities discovered later on. And so we're able to, in this case, it looks like we don't have any vulnerabilities in this package. Let's find some that do. So here's a Node.js image. So when we scan the image, we're going to make sure that all of the vulnerabilities are displayed in a layered scan. So that here we can see there are 6 critical vulnerabilities, and here's the run the command that was used to build this layer of the image. We're also going to show you these vulnerabilities by the package or library module that we detect, and how many of those are fixable, where there's, in this case, there's no fix available for this, whereas these 2 are fixable. And there's also going to be compliance checks, Docker image checks, as well as inspecting images for secrets and more loose file permissions and other types of compliance violations. So these are all checks that should be done. Now back to the automation, of course you can manually add new registries to be scanned or repos to be scanned. But all of this can be done either through the config map, which can then be linked into your Terraform script, or it can be done through the REST API. So when you deploy your infrastructure, if you have a staging or production registry that containers are going to be deployed from, that should be automatically configured so that NuVector is automatically starting to scan those registries, and you're going to get all these image scan results. The reason that that is critical is that the next step that we want to automate is admission control. So if we go into policy under admission control, you can see here that we can add a number of different rules that are going to block vulnerable or unauthorized deployments into my production environment. I can block specific vulnerabilities. I can say it must be scanned by NuVector, otherwise it's going to be blocked. Here we have a sample PSP replacement because PSP is being deprecated, run as privilege, run as root, IPC namespace, et cetera, or it can be more of a customized rules, block vulnerable deployments if there's a fix available. So this is only going to block if there's a fix available. So if I say high severity with fix, and we can even say reported more than 7 days ago, because we give our developers a week to remediate vulnerabilities. So this is really the first gate that's going to be able to automate the protection into that production environment. So that's admission controls. And then once workloads are deployed into the production environment, NuVector detects them automatically. We create what's called a NuVector group for each of our applications that we see deployed. In this case, Nginx talking to Node.js, which is then talking to my Redis pod in my demo environment. And so this is probably one of the most critical areas that you can automate the security into your deployment. And this is what I referred to earlier when I said, before we're going to deploy our applications, we're going to deploy the security policy as code for those applications. So let me take you through the flow of how this actually typically is done. So in a typical environment, this would be, let's say, a staging or test environment, and I've got my my application stack running here in my demo namespace, and Nginx talking to Node and Redis. I also had MySQL running, but for this application stack, it's just these three. And what I've done is I've already put NuVector into a what's called a discover mode for these applications. So I'm able to, in that discover mode, learn all of the behaviors. So for example, if NuVector is in a discover mode, when I run my test traffic through this application stack, I'm going to learn all the behavior that this Nginx pod is doing. And so I'm going to create these learned rules of network connections that we observed, as well as all of the processes that occurred, and I can even create specific file access rules. So in this discover mode for my application stack, I've learned all that behavior, and just to be safe, I've put it into monitor mode because I don't want any other errant behavior to be learned. And then what I can do is I can select my application stack and I can export this. And this is where we're going to export this as, and this is what we call security as code for NuVector. It's in, or it's using a custom resource definition in Kubernetes, which is called the NuVector security rule. Apologize for the small type here. And so you can see here that in this human readable YAML file, we're defining that the Nginx pod in the demo namespace is going to allow any protocol coming in. It's going to allow to do egress to a kube DNS system. It's going to allow HTTP in to Nginx. It's going to block access to that file unless it's a appropriate application. And so all of the things that we saw in the console here are expressed in this file. The processes being allowed for this are listed here. And this can be reviewed by the development team, by the DevOps team for accuracy, as well as maybe there wasn't a connection that we expected, but it wasn't initiated from our test scripts. Or maybe there's a connection that should be allowed using SSL. So I can simply add that to this document here, run it back through my test, and then check it into my Git repo and deploy it into my production environment. So that's exactly what we did. I don't know why my file was circling there. So that's exactly what we did in that Terraform script. We exported that, we customized it, we checked it into our Git repo, and then we used it in that Terraform script to push those policies into our production environment. So, and it's very simple. You simply go into your terminal, or you can apply this through Terraform, kubectl, apply that YAML file. And all of these rules that we see here expressed, the network rules, the process rules, the file rules, will show up in your production environment. At that point, you're then ready to deploy your application stack. Because when you deploy your application stack, NuVector will be protecting that application. Any activity that is outside of these rules that we talked about, these allow rules, will be deemed as suspicious activity. And in a monitor mode, we'll just alert you if there's suspicious activity. But in a protect mode, if we switch these into a protect mode, then we will actually block a suspicious network connection, process, or file activity. And the way you can see this or visualize this is in this network activity diagram. You can see your Nginx pod here. You can see your Node.js, your 3 Node.js pods. You can see the allowed communication between those pods here as well. So if I, and you can also see, for example, this is a red line we're seeing here. So this is an unauthorized connection. What that means was that there was no allow list rule that allowed this ingress into this Nginx pod. And that's why it's set to monitor mode. So we just alerted on this violation. That is how you can really get the protection in place as part of your infrastructure deployment and go all the way down into workload protection. Now, once we detect any of those violations, they're going to be showing up in the security event notification, process violations. This is a DLP violation where we detected a credit card in the payload. So any of these are going to be showing up into either the security events notifications or the vulnerability scan notifications. And that's probably the final area of automation integration that I want to talk about today, which is the last part of automating and secure infrastructure as code should be the integration with any types of notifications or SIM systems that you need when there's security events to go into your enterprise SIM system. So that could be configuring one or more webhooks to be able to send out notifications, in this case, Slack notification, but could be to really any case management system or other system that you use. And then, of course, to SIM systems through syslog, you can choose what level and type of events and the format of those events. So all of this can be pre-configured during your deployment of the infrastructure in NuVector so that everything is being monitored and then all of those security events are starting to be showing up in your notification systems. One last thing I'll touch on briefly is a little bit more advanced responses that can be configured to automatically happen. In the area of what we call response rules, you're able to create a specific rule looking for a specific type of event. So this could be a network violation, a container file access, or a privilege, or a package has been updated. There's a whole number of security events we could look for, or vulnerability scan events. And the action could be to send a customized webhook, one or more webhooks, or you can actually quarantine that container automatically. So these are all really more advanced types of automations that can be built in, and it can be part of your initial secure infrastructure deployment. All right, so I think I've covered everything from deploying the infrastructure, securing the infrastructure, as well as finally deploying your security layer, your applications, deploying your secure applications, and then being able to monitor for security events. Hope that helps to provide some framework for you to think about security as you automate your deployments. and we can see if there's any questions. Do put questions in the Q&A, and I'd be happy to answer them.
Yeah. Awesome. Thank you so much, Glenn. That was really informative and super great stuff.
Thank you.
We did have, yeah, you're welcome. We did have a bunch of good questions come in here. First off, can you produce a full software bill of materials of a product using this tool? And can this list display the open source licenses? So I guess that's two questions in one.
Yeah, so the bill of materials, I kind of looked at it or showed you that in the module list. So anytime we scan an image, we'll show you all of the contents and modules, packages, libraries that we can see from the image. And you can see that in the console, or we can send that out in the scan results, or you can pull them through the REST API. We do have a partnership with Sonatype with Nexus Lifecycle. All of our scan results go back into Nexus Lifecycle. So for the second part, we don't check open source licenses. That's an area that Sonatype Nexus Lifecycle would be able to not only check open source licenses, but do a number of other artifact management and policies that can then take advantage of the scan results that we saw in NeuVector.
Okay, gotcha. All right, let's see here. I'm just reading through some of these here. Here's one. Is NeuVector a sidecar?
Oh, no, we are just a container. So you saw some of our containers. So a single container, which is the controller. If you doing scanning, there's the scanner container. And then I think you're referring to the actual workload protection. There's one enforcer. I don't know if you remember, I showed the enforcers. Those are one of NeuVector container on every host or worker node, or wherever you deploy the enforcer. So there's really a single container required. We believe sidecars are too heavyweight. If you have 1,000 containers running on that host, you're going to have 1,000 sidecars. It makes for performance issues, scalability issues, and management issues. So we don't require, I know some technologies require a sidecar to be injected. We can do all of our layer 7 packet inspection, process inspection, blocking, all of that stuff that I talked about briefly, we can do with just that single enforcer container.
Okay. All right, let's see. Can the component list be exported into SPDX or CycloneDX file format to be able to check future vulnerabilities myself?
Sure, it's all available either in a JSON format or in the case of our Jenkins plugin, it's HTML plus JSON and available through our REST API. We do have a little sample demo module where we convert that into a Cyclone DX format. And of course, you know, that's our partners at Sonatype are big supporters of the Cyclone DX format. So that's something that can be done as well.
Okay. Here we go. How can we detect the change or drift either done manually to infrastructure or through Terraform deployed infrastructure?
Yeah, so NeuVector will do some of that. So it depends on what infrastructure we're talking about. So there's a bunch of checks in the Docker and Kubernetes benchmarks that are kind of host related or orchestrator related. And so we continuously run those. In addition to that, if there are specific configurations that you want to monitor or check, you can write custom compliance checks into NeuVector and we'll continuously run those and alert you if we detect any drift in those configurations. If there's changes in the Terraform configuration itself, there are other tools out there. I believe Fugue, another Sonatype partner, is in the business of Terraform and IaC configuration checks as well. So there's other tools that can do that.
Okay. All right, let's see. There's a couple questions that kind of follow on from this. Can it be integrated with AWS ECS cluster?
ECS clusters. I haven't, we use ECS ourselves. We know how to write tasks and things like that. I haven't specifically looked at AWS to see if they have if they are a provider module for ECS, EKS, or they call it EKS, right? Their Kubernetes system, definitely, we've used that. ECS, I would imagine there's a provider module for that. But if not, any of this can also be launched and deployed through Terraform by just scripting that.
All right. Okay. Let's see. Here's a great one. How does secure, not that the other ones weren't great. How does secure infrastructure as code relate to a zero trust security model?
Oh, that's a big question. I could do a whole webinar on that topic itself. But in a nutshell, we'll take a step back. Zero trust security model is really don't trust anything, right? Everything is untrusted. So you specifically have to declare what is trusted. And so I've touched on various parts of that today, in that when you deploy your infrastructure, you define trusted connections, trusted users. You assume all users are untrusted, so you don't just let any user in. You have to pay attention to those role-based access controls. And then in terms of the actual production environment, what I showed there with the CRD, which essentially is declaring the allowed behavior of your application. So what network connections can it make and protocols can it use? What process and file activity can it initiate? And then everything else is deemed untrusted. So that is is an example of a zero trust security model, as well as a declarative security model, where you're going to declare the allowed behavior, everything else is untrusted and can be blocked. The reason that's important to understand is that it's different than in the past, where we had more of a deny list, here are the untrusted, as opposed to zero trust security model. So we had signatures, patterns that we had to constantly download. Those were constantly out of date. They generated false positives. Hackers, had new ways to get through that. There weren't signatures to detect those. So those weren't as effective in those IDS, IPS systems or WAF systems. And by moving to a zero trust security model, it's a much more effective way of enforcing security on your applications. And what's really enabled that is the move to microservices, where applications are being broken up into little microservices, and each one has a very specific task that can be described very well and bounded. Instead of one big, huge application where you have no idea, the process, the file, the network activity that, this group is going to introduce into the application, too hard to keep track of. And that's why we had the previous security model. But as we move to this new microservice and cloud-based security model, it really enables an opportunity for a zero trust security model. So hope that helps. That was a quick overview of that. And again, it could be a very in-depth topic follow-up.
It could. Maybe you can come back and do a whole other webinar on that.
Sure, I'd love to.
That'd be awesome. All right. I think that's about all the questions we have time for right now. But folks, do not worry. If we did not get to your question, we're going to round all those up and send them over to Glenn, and he will be able to follow up with you afterwards. No problem.
Yeah, thanks for joining us today.
Yeah.
Appreciate your time.
Absolutely. These are always so fun. All right, folks. So just as a quick reminder, the session has been recorded, so you can go back and watch it again. We'll be sending an email to you with instructions for accessing the webinar on demand. So keep an eye on your inbox for that. Again, the handouts are available under the handouts tab there for you to download. And I know Glenn had a number of great links and stuff throughout his presentation. So make sure and download those, and then you can go through and click through those links. All right, now it is time to announce our Amazon gift card winners.
I'm glad I stuck around for that.
I know, maybe we'll win this time. All right, so our first winner today is Francisco J. Congratulations to Francisco. Next winner is Yasser E. Congratulations, Yasser. I hope I'm pronouncing that correctly. Third winner today is Nick R. Congratulations to Nick. And finally, our fourth winner of the day is Paul C. We didn't win, Glenn. I guess we'll have to come back next time and see.
All right, I keep trying.
I know. There's always next time. Thank you all so much for our Amazon winners. We're going to send you an email with instructions for claiming your gift card. So keep an eye on your inbox. If you don't see it there, make sure and check your spam folders. Thank you all again for your time, and Glenn, for your great presentation. We hope to see you all again soon at another DevOps.com webinar. I am Sharon Florentine, signing off.